Welcome student in Christchurch Convent Digital Classes, Class 11th, Subject Chemistry, Chapter 2, Part 8. In this session we will see emission and absorption spectra. So emission spectra means, or spectrum means, there is a radiation which is emitted or exited by some radiating body, and absorption means any body is absorbing the particular color of light. And so first of all we will see atomic spectra, absorption and emission spectra. So this is the phenomena that gave serious blow to Rutherford model, because Rutherford model cannot explain the about emission and absorption spectrum of atoms. So it can be defined as splitting of light into various colors or color bands is called spectra. So what is atomic spectra? It can be defined as splitting of light into various colors or color bands is called spectra. When we see Vibgyor, the violet color merges into another, and likewise the other color merges into another. So generally Vibgyor is composed of, from right to left, V means violet, I means indigo, B means blue, G means green, Y means yellow, O means orange, and R means red. So you can see in the color diagram, the visible light is split into its 7 constituent color, that is Vibgyor, which are present in sunlight. So in that case, where one color merges into another, there is a no definite boundaries, so that spectra is called continuous spectra. So when color merges into one and into another, then that kind of spectrum is called continuous spectrum. If we study it for atoms, the spectra is called discontinuous, obtained is discontinuous spectrum. For example, the study of spectra is called spectroscopy, which is a branch of physical chemistry. Spectroscopy is done in chemistry. Atomic spectra are of two types: emission spectra and absorption spectra. We'll see one by one what are they. First of all, you can see emission spectra. It is a kind of atomic spectra. It is obtained when emitted light is analyzed. The light is analyzed by spectroscope. The light is emitted when an atom is heated or electric current is passed. These are referred as fingerprints of atom. So these are the characteristic for any atom, means they are unique for any given atom. So we have the database of emission of spectra, and researchers continuously studies the emission spectra. If it does not matches with our database, that means that particular atom is not known to us, and if matches, that means it is a similar of another atom which is already discovered. So this also helps in the discovery of new element and their atoms. When we analyze emitted spectrum by spectroscope, we can see the image as shown in figure. In this slide, Now, when we analyze with spectrometer, the spectra obtained is discontinuous. When white light is passed through a sample, it absorbs few radiation and then transmitted light is analyzed. Now, for example, emission spectra of hydrogen atom. If the hydrogen gas is taken at low pressure in a tube, in a glass tube, or you can say in a cathode ray tube, then light emitted by it was examined, and the following red color or images is obtained as shown in the particular this slide. It was noticed that spectrum obtained consists of large number of closely spaced lines which falls in different region as shown below. So continuous spectrum, then after that, in continuous spectrum there are no lines or vertical columns band or vertical columns. In absorption spectrum there are few lines are found. Here 4 lines are showing to you. In the second row, band of 7 lines are showing to you. They are not continuous. There is a black region between them. You can see in the diagram here is no band lines are there. In this, the color are merges with each another in continuous spectrum. In absorption spectrum there are some regions where black color is obtained. So you can see here 4 black colors are obtained. Okay, and in emission spectrum there are totally black region, but at some reason or at some point of time you are here getting red region, green, violet and violet. So the first continuous spectrum, there is no separation or boundaries, the color are merges with each other, so this is continuous spectrum. In absorption spectrum there are colorful region, but columns of black portion or dark portion is also there. But in emission spectrum there is totally black region is there, and only few colors of lines are showing or columns are showing to you: red, green, violet. Now Rydberg gave the formula for determining the wavelength of these lines. So these lines which you can see in the absorption spectrum or emission spectrum, red and green, if you want to find the wavelength of these lines you can use Rydberg formula. And Rydberg gave the formula for determining the wavelength of these lines, that is 1 upon nu bar or wave number. 1 upon wave number is equal to r is a Rydberg constant multiplied by in big bracket 1 upon n1 square minus 1 upon n2 square, where nu bar or v bar is wave number, where r is the Redwork constant and its value is 1.097 into 10 raised to power 7 meter inverse. N1 and N2 are whole number, where N1 is constant and N2 varies. So for particular series like for Lyman series, N1 is always 1 and N2 can vary from 2, 3, 4 and so on. For Bama series, N1 is 2 and N2 is 3, 4, 5, 6, 7 and so on. For Paschen series, N1 is always 3, N2 can be 4, 5. For bracket series, N1 is always 4, N2 can be 5, 6, 7. and for front series n1 is 5 and n2 can be 6, 7, 8. So this was give Redwork formula. Now one problem is given to you. Calculate the wavelength of the spectral line obtained in the spectrum of lithium ion Li2 plus ion when transition take place between two levels whose sum is 4 and the difference is 2. So suppose transition take place between the level n1 and n2, then n1 plus n2 is 4 and n2 minus n1 is 2. Here minus n2 minus n1 is there. Here n2 minus n1 is 1 because if we minus, sorry, 2. So here in place of plus you can write minus, and in place of 1 you have to write 2. So solving these equation we get n1 is equal to 1 and n2 is equal to 3. So 1 upon wavelength is r is equal to 1 upon n1 square minus 1 upon n2 square into z square. For lithium ion, the atomic number of lithium is Z is equal to 3. Lithium, atomic number of lithium ion is 3, so Z is equal to 3. So 1 upon wavelength is equal to 109. This is the value of Redwork constant, 1.097 into 10 raised to power 7, or you can write 70 after this. So we have taken here, I've taken here 109, 1,09,667, 1,09,677 centimeter inverse. We have taken the value in centimeter inverse, and in place of n1 we have put 1, and in place of n2 we have to put 3, not 1. So this become 1,09,677 multiplied by 1 upon 1 minus 3 का स्क्वायर 9 हो जाएगा, और यहाँ भी 3 का स्क्वायर 9 हो जाएगा. So if we simplify this, we'll get 1 upon 1,90,000. We have to transpose this. So finally, if you solve this, you'll get this. So do some correction here. In place of plus, we have minus. In place of 1, we have to write 3 here. Here also 3 square. And we have transposed here. Wavelength, we have transported here. And this become 1 upon. Thank you for watching. See you in the next video.